Pure crystalline substances have a fixed and sharply defined temperature at which they change from solid to liquid. Since the melting process requires thermal energy input to disrupt the crystal lattice, the temperature remains constant while melting takes place, provided that the two phases are in equilibrium. In a laboratory melting point determination, this condition is not usually achieved, and the melting of the sample is observed to occur over a small temperature range, typically 1 to 2 degrees Celsius. The situation changes when the sample is not completely pure, and the presence of impurities in the sample will cause melting to occur at a lower temperature and over a broader range. This depression of the melting temperature increases as the amount of impurity increases, making the observation of a sample's melting range a useful indicator of its purity. Our lab uses Fischer-John's apparatus and Vernier melt stations that can melt solid substances from 30 to 260 degrees Celsius. For the Fischer-John's apparatus, first take a microscope cover glass and place it on the heat block. Use a spatula and take a small amount of solid sample and place it on the cover glass. And place another cover glass on top like a sandwich. Turn on the power switch and control temperature knob. Look through the magnifying glass to watch until the solid sample starts to melt and record the starting temperature from the thermometer. Observe the solid sample until it is all melted. This will be your final melting point range. At this point, you can turn down the temperature control knob, remove your sample, and place a metal crucible filled with ice on the heating block to cool it for the next person. For the Vernier melt station, you will need to download the Vernier Graphical Analysis app on your phone. Open the app, click on Sensor Data Collection, Proximity Connect, and find your serial number of your melt station located in the lower right-hand corner of the instrument. Click Connect and Done, and click Collect at the top of the screen. Load a small portion of a solid substance into a capillary tube. The narrow capillary tube has a diameter of 1.5 millimeters and has been sealed at one end. The depth of the sample in the tube should be 2 to 3 millimeters after packing the sample in the sealed end by tapping the tube on the lab bench. It is essential that the sample is completely dry and free from residual solvents. Carefully place the capillary tube into one of the 3 slots in the aluminum heating block of the melt station. You can tilt the melt station toward you slightly for a better look at the heating block. On the melt station, turn the control knob to the rapid heat area. The red LED will come on, indicating the melt station is heating. While the sample is heating, closely observe the sample for changes. When the temperature is within about 10 degrees Celsius of the expected melting temperature of your solid sample, turn the control knob to that temperature, slowing the heating rate. As the temperature nears the melting point, the tiniest crystals adhering to the wall of the capillary tube will be seen to melt first, followed shortly afterwards by the bulk of the sample beginning to shrink, collapse, and liquefy. At the first indication of the solid melting, note and record the temperature, and also when the solid fully liquefies, record the temperature range. Click Stop on the Vernier app when complete. After the experiment, turn the control knob to the fan cooling setting. The blue LED will come on, indicating that the melt station is cool.